Okay, here we are, problem 17. Has anybody else besides myself been over to Europe before? We have these cathedrals with the flying buttresses. And really they are an engineering marvel of their time, because to support these enormously large cathedrals, it was before the technology of steel that eventually built the skyscrapers. So it really is an engineering marvel for the time. And so what we're going to do is look at this particular flying buttress, which is sort of just a parabolic arch that creates weight support up above there, because you can see a considerable amount of building mass above that vertex there, can't you? So anyway, we are given 2 points, and we are being asked to find 2 things: a quadratic function that models the shape of that arch, plus to state that function's domain. Do you have any ideas of how to do this problem? Just something, can you think of anything we've looked at that might help with this? Okay, well, I will give you something, but what I'm going to show you is something that we actually, when I had you take notes, remember that one time? I had you take notes on what we call a vertex form. It's a vertex form of a quadratic equation, and what it is this one here. It's f of x is equal to a times, we have this x minus h squared plus k. You remember writing down something like that before? Okay, Victoria remembers. And what happens in this format here, the vertex is the coordinate pair of the number h comma k. And one reason I like to bring this up now, and even that I brought it up to notes, this whole deal where a function has an a, an h, and a k, this is going to replicate itself over and over again throughout this entire course. And so if you're familiar with how to deal with this h and the k and the a, then it's eventually going to make things easier as you go along in the course. Okay. Now, how would we apply this equation to working out the situation at hand? Are we given a coordinate pair for a vertex here? We are, right? And what coordinate pair are we being given? Point C, right? We are told that that is your vertex of the arch. So how can we go ahead and take that knowledge and put it in with this to start being able to solve this thing? What is h going to be and what is k? So you're saying h is 2? Yes. So this one here, h is equal to 2. Thank you, Elijah. What is k equal to? 12. So we can take this and plug this into this formula and really start working on this thing. So we're going to have f of x is equal to a. We don't know a yet, but we know that h is 2, right? And we know that k is 12. All right, so that's our start on the deal. But in order to find the equation for that, now that equation's not, because for an equation you just want to have one unknown, right? How many unknowns do you see here in this equation here?
3.
There are 3 of them, right? There's the f of x, there's the a, and there's the x. What other information can we use that will fill in 2 of these unknowns so we can solve for a third?
8 and 6.
8 and 6. Okay. What are we going to do with this 8 and 6 to place it over here?
8 goes to x and 6 goes to 8.
Okay, the 6 will go over here. Is that what you're saying?
No, I said the 8 will go right there.
Okay.
I don't know for sure.
Yes, let's do that. So what we have is x is 8, right? So we're going to put the 8 right here. Okay, so if we have an input of 8, we get an output of 6. So now we have an equation with how many unknowns? 1. So now it's just a matter of our basic algebra to figure out what a is. Now, would you expect a to be a positive or a negative number? Why negative?
Because it's positive and negative.
Well, I'm thinking of that. Now, maybe you're right about that logic. Yeah, because you have a downward opening parabola. That's why a should be negative, so you should know that. So anyway, what you do is you work this out. You're going to get 8 minus 2 is 6 squared would be like 36. So 6, that's going to be 36. A plus 12, right? And then subtract 12. You get 36a is equal to negative 6. And then what is a going to be equal to?
12.
So you're going to get negative 1/6 once you simplify, right? So now do we have an equation that works? Yeah, we're right down here. So that would be f of x equals negative 1/6, and we have x minus 2 squared plus 12. So that's going to be it. One thing you can do is you can check in your calculator. And what's our domain of this thing going to be here? Because it says find the domain, right? What's our domain of this thing? What are the allowable x values here?
And it will be 2 less than or equal to x less than or equal to 8.
8. So 2 to 8 will be our domain. All right? And then one last thing you could do with the calculator is you can go over here and put in like negative 1/6. We'll put in x minus 2 plus 12 and see if you get that same point here, right? You should get 2 points on here. You should get 2 comma 12, that's right, isn't it? And then you should get 8/6, right? And that's there also, so that checks out, okay? All right, any questions on this one here? Does this look really hard? It does?
To me, yeah.
It does look hard. What's the hard part of it?
I got lost after you get 36A.
So this thing here,
Yeah.
so just the algebra work it out, because what you have is you have,
Well, how did, like, for the answer, why did you put the parentheses x minus 2, like, why did that have to go there?
because that's the form, that's the vertex form. You see it's the same form. So the 2 that is here shows up over here, and the 12 that was here shows up over here. And we figured out with the additional data point we had, we were able to work and figure out what A was. Does that make sense?
Yeah, I guess. Like, I just don't understand why you had to put that back into the answer. If you didn't put 6 and 8 in there.
Well, 6 and 8 was another point we had to help us find out. Because this vertex alone didn't give us enough information. After using this vertex, we could only get this far. The other point enabled us to get this far, and then we were able to solve for A. And then, after we solve for A, we're able to take this -1/6 and place it right here.
Okay. All right, I understand.
So what we were doing, this whole thing was about finding A,
Yeah.
and then that became this once we found out what A was,
All
okay?
right, I got it.
All right. What I want you to do is 18, very similar type problem.
Is it the same formula?
Let me look at the problem first before I answer your question. And I think I'm probably going to have you answer your own question once I ask you a question on this. Okay. Let's read this. A red velvet rope hangs between two stanchions and forms a curve that can be modeled by a parabola. So, what kind of function models a parabola? Let's look at this one. Here it talks about, includes an arch. Okay, here on 17 is it doesn't mention parabola, but mentions quadratic function, right? So what kind of function models a parabola? And they tell you it's a quadratic function here too, right? But since they told you parabola, they wouldn't have even had to mention this anymore, right? You could have been just find a function. We wouldn't have even need to know this here because we said parabola, it already means it's a quadratic function, right? And what is the vertex form of a quadratic function that we talked about? I wrote it down here, right?
It's the same.
That's the same. And this is one thing that's going to be a deal for our course because we're going to find like the profile of cables of the Golden Gate Bridge and other things. We're going to do this thing here more.
So since there's 3, how do you know what to use?
Well, what did you say, 3?
Since there's 3 points and not 2 like the other one, how do you know what point to use?
Okay, very good. Anybody have a question? Victoria asked a question. It's a good question. In problem 17, for instance, you had 1 extra point, but in this instance here, you're given 2 extra points. How does that change things? Pardon me, what did you say?
One of them's not needed.
One of them is not needed. Exactly. Okay. And the takeaway is when it comes to finding a parabola, what you need is if 2 points, if you have a vertex and one other point, you can find it. Okay, so yes, 1 is not needed. So basically you have to do what? You have to choose one and go with it.
It doesn't matter.
It doesn't matter.
You're gonna get the same answer either way.
You get the same answer either way. And because of that, I don't know if we want to, if some people want to do it one point and some the other point, to kind of experiment on that, that'd be kind of cool. Who's using the 7,4? You are? Anybody using the 1,4? You are? Okay, good. So when we do that, that'll help. And really, it could have been another point. It could have been, if we knew this little point here, this input value for 3,6, let's say it is, we could use that too. So any other point besides the vertex, we would use and be able to find it by the equation, the function. Okay, for this one here, do you want me to write down the answer and see if you got that as an answer? You want to do it that way? Okay, then we can work backwards as needed. We had people who did it differently. So you should get, the function should be f of x equals 18th x minus 4 squared plus 3.5. Is that what you got? No? Luke, you didn't get that? Did you didn't get that? Did anybody get that? Steve-O, did you get this?
Yeah.
So Steve-O got it, okay. Okay, so you ready to just go over this? Jace, did you get this, Jace? Elijah, you get it?
I didn't get it right.
Okay, let's go look at this.
I got negative 1/18.
You got negative 1/18?
Yeah.
Okay, good. We'll work it out. Now again, we have our vertex. Okay, what is our vertex going to be? 4, 3.5, right? And so our basic function is going to be f of x equals a times x minus 4 squared plus 3.5, right? Now the next thing we have to do is decide which point to use. Now like in second period, I think we use this one. But why would you use, maybe you want to use point A instead?
Smaller numbers.
Smaller numbers, right? So smaller numbers to work with, so the arithmetic might be a little easier. And so if we use that, this 1, 4, where do those things go? Well, this is where our 4 goes, right? And then we have A, and now we have our 1, what, that's 1, right?
Yeah.
Minus 3,
No, minus 4.
minus 4, excuse me. Thanks for catching me. 4 squared plus 3.5. And so now we can just say this is going to end up being negative 3 squared. So that's going to be 9. That'll be positive 9.
Oh, 9. Oh, yeah. That's
Positive 9, right. So we'll have 4 is equal to 9a plus 3.5. Okay, and then we subtract out 3.5. Subtract out 3.5, we get 0.5 over, well, let me write this out, excuse me, I'm kind of working ahead of myself. What we have is that we have 0.5 is equal to 9a. And if we divide by 9, 0.5 divided by 9, it's 1/18, right?
So I got that, but I just didn't like.
You didn't recognize it?
Yeah, I guess I did get that, because I got the 0.5 equals 9a, but I just stopped there, put it on 2.
Yeah, and so what you have is you have like a fraction divided by 9, but if you multiply, you can make it a prettier fraction if you multiply this by 2 over 2. And so 2 over 2 is, 2 times 0.5 is 1, and then 2 times 9 is 18. So 0.5 over 9 is, that's a real answer, and it's a good answer, but it's not as pretty as 1/18th, right? It's just a prettier fraction that way.
So, I got a question.
Yes.
I forgot how to put the decimal into a fraction to get the answer.
Oh, really? So you got like point
Like, I
oh
got the-
something,
Yeah.
oh something, yeah. Let me show you what that is like.
Point 0, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5.
So you get that thing right there, right? Well, if you get this thing right here, you can change it back to a fraction, I think. If you go to math and you want to go to fraction right here, press enter twice, we'll change that.
Oh, okay, I got it.
You see what we did there? Okay. No, that's a good question. Good questions
I got
all.
the answer then.
So then we have our equation is going to be f of x is equal to 1/18th. Then we have x minus 4 squared plus 3.5. And what is our domain for this thing? It'll be this thing here, right? 1 to 7. So that'll be our answer.
7.
Right. Did anybody check that in the calculator? You did work, Steve? Okay, good. Yeah, and the thing about it is, if we were going to use if we use 7,4, what that would be is, this 4 would be exactly the same, right? But you would have 7 minus 4 instead of 1 minus 4, and then you'd still get 9a, wouldn't you? But see, I'm thinking the 7,4 might actually be easier because you wouldn't have to worry about that negative number, possibly. So it's hard to tell. But in general, I like to go to the smaller numbers first. In this case, smaller numbers didn't help you that much, but.
I forgot why I got the negative down.
Yeah, and so that's where your negative came from, huh? Right, Steve?
I pushed the 4 with the 3.5.
Oh, okay. All right, yeah.
I subtracted 3.5.
Oh, okay, yeah. Oh, so I see what you did, yeah. So you got a negative number there.
Yeah.
Yeah, okay. All right, very good. All right, what I did is while you were working on your problem there, I handed you a graphic organizer that said things to know about inverses of functions. Do you see that? What we're going to do is with class today, we're going to take notes on this, because we're sort of segueing into working on inverses of functions. Does anybody know what an inverse function is? I'm going to give you a demonstration of what it is. In Mexico City, in the summer, I was watching the news, and it said the temperature was like 25 degrees. Right? And I'm thinking it's summer and it's 20. Now I know Mexico City is 7,000 feet above sea level, where it is a little bit cooler there, but I'm thinking 20 degrees. Are you kidding me? That's like a winter temperature. And yeah, it's a farther south country, but Mexico is still a northern hemisphere country, right? They have the same general seasons we do, generally, right? And I'm thinking, how did they get 20 degrees? What? How in the summertime is there going to be a 20-degree temperature in Mexico City? What's your theory? That'll be another type of scale, right? Another type of measure, in this case Celsius. And so that's exactly what it is. Okay, but I want to, as an American who doesn't have that understanding of the Celsius scale, I want to figure out what the Fahrenheit temperature is so I can understand what it's like in Mexico. I'm getting ready to go down there next week. How am I going to dress for a certain temperature? Fortunately, there's a conversion formula. It goes like this. Or before I write it down, does anybody know what it is? Okay. Well, what it is you take 9/5 of the Celsius measure and add to it 32. Okay? And now we want to find out what our temperature is like. So we'll pay 9/5 times 20 plus 32. Does that seem right? And then 9 times 20, that's going to be 180. And 180 divided by 5, let's see, that's going to be, what is that? 3 times there, is that what that is? And then 15, and then 3, bring down to 0, 6. So that would be 36 plus 32, which is going to be 68 degrees. Okay? So we know that's 68 degrees. Okay? Now, but what an inverse function is we are going to instead figure out what if we were given a Fahrenheit measurement and wanted to find Celsius? How would we do that? Well, how we would do that is we would solve for this other variable here, right? How would we do that? Subtract 32. So we'd have 9/5 of our Celsius is equal to our Fahrenheit minus 32. And then what? Or multiply by 5/9, right? So that will cancel out. So our degrees Celsius is going to be equal to 5/9 of our degrees F minus 32. And so what we have here is these two functions right here are what we call inverses of each other. And so, I mean, this, I think, a pretty fair example. So this is an example of that. And I'm going to go over here to this thing right here. We're going to take notes on this. And this sheet right here, you can glue it in your notebook or staple it in somewhere, but it should be part of what your situation, what you have. Okay, first thing I'm going to put down here is inverse function notation. Okay, inverse function notation, it's going to be f -1 of x equals something. So you'll see this -1 like in the place of an exponent. Well, that just means an inverse. And if you look at your calculator, like on the sine and cosine and tangent keys, you'll see that sine -1, that's an inverse. Okay, I'm going to write down some things to know about them, and so this becomes sort of a guide. There is in inverse functions, x's and y's switch places. So if you see a table with data like this, the inverse function of this thing is just going to be like this, right? Just x and y switch places. Another one, the domain of a function is, I put equal sign, the range of its inverse function. But that, if you think about it, goes along with x's and y's switching places, doesn't it? So that's something to know about it. Another thing to know about inverses functions is that an inverse of a function is not always a function. Okay, so those are three things right there. This fourth thing here is there is a four-step algebraic process to find an inverse of a function. And for us, most of the time we spend working on inverses is going to be related to doing the algebra to do that four-step process. Okay. Another one here is that two functions that are inverses of each other each other reflect about the line y equals x. And that's really important too. So these will be, I'm circling the kind of the most important things here. This other one here has to do with compositions of functions. I'm not going to write the whole thing down. I'm just going to put compositions related. We're going to get into composition of functions in pre-calculus. So evaluating composition of functions is another way, is a final way. But we're going to spend most of our time on these two circled ones. And I'm briefly going to make a demonstration now of that.
What's that say?
This here,
Yeah, the very top left.
compositions related. I just put compositions related. And I'm not going to go into detail on that right this second, maybe later. But that's one we'll cover more in pre-calculus. Okay? Now, what I'm going to do is show you that I talked about the four-step process of finding an inverse of function. This is pretty much it. What we did here, or what I did here, that's pretty much solving for the thing. So so all the problems that you do for solving for inverses are going to look kind of like this, kind of that level of algebra. Does that look too difficult? No, it shouldn't be that difficult for you guys. I want to show you one more thing. Is graphically, this function right here that I'm graphing is a cubic function. Okay, and I don't know what it is exactly. We could say y equals x cubed. I know it's not a perfect drawing of it, right? No, y equals x cubed. Y equals x cubed. Now the inverse function for that goes like this. Okay, and this one is going to be y equals cube root of x. But do you see that these things here reflect about this line y equals x? I mean, I didn't make the greatest drawing there, but these functions are inverses of each other. So if you notice graphically and are able to perform the algebra relation, that's really the level of expectation we have for that. And ladies and gentlemen, that's what we have for today. Okay, any questions on this right now? Okay, we'll be working more on inverse type problems tomorrow.